Hello. Let us start the questions in Fluid Mechanics 1 in afternoon session for civil engineering. Let us start the first question. Look at this question. This question belongs to Bernoulli equation topic. Subtopic is flow measurement from venturimeter. Let us read the question. A venturimeter, as shown in the figure, not to be scaled, is connected to measure the flow of water in a vertical pipe of 20 centimeter diameter. Fine. This pipe diameter is given as 20 centimeter. This is 20 centimeter diameter pipe. Assuming acceleration due to gravity is 9.8 meters per second square. When the deflection in the mercury manometer is 15 centimeter, important data. The flow rate in liters per second, rounded off to 2 decimal places, considering no loss in venturimeter, is how much? Let us mark important points over here. First of all, he has given you this diameter. This is a pipe diameter which happens to be your D1. So let me name this as D1. He has given me acceleration due to gravity. He has given me the deflection, the manometer is 15 centimeter. Also given me that the fluid that is flowing over here is it happens to be water, while this over here is mercury. The manometric fluid is mercury. Furthermore, a very important point which he has mentioned is consider no losses in the venturimeter. Now, what does this point imply? This particular phrase, no loss in venturimeter, implies that you are going to consider the coefficient of discharge CD is equal to 1. We know that if there are no losses, CD happens to be 1. That means theoretical discharge and actual discharge, both of them are going to be same. Fine. With all this data, let us apply this in the formula and get the answer. One important thing before I move any further, I would want to mention is, people have got confused probably with this 30 centimeter. This over here is an extra data. It does not influence the answer in any way. Whether it is 30 centimeter, whether it is 0 centimeter, whatever it is not going to influence your answer. Please remember, whenever we calculate the value of discharge, the deflection is important. That is, this 15 centimeter is important. Okay. The offset between these two limbs is not at all important for us. Moving further. Let us now go to the next slide to solve this question. I can start with the formula. The formula for discharge we know, Q, which is theoretical and actual, both of them are same in this particular case. So I'll write Q is equal to pi by 4 D1 square into D2 square upon root over of D1 power 4 minus D2 power 4 multiplied to root over of 2G into manometric deflection HM multiplied to SM by SW minus 1. This happens to be the formula. SM over here is the specific gravity of manometric fluid, that is mercury. SW happens to be the working fluid specific gravity. You can take the ratio of densities, ratio of specific gravities, ratio of specific weight. All of them are going to be same, as I mentioned previously in the classes also. Now let us apply these numbers. We know the value of D1. Let us go to the previous slide. The value of D1 over here is this diameter, that is 20 centimeters. The value of D2 over here is throat diameter, that is 10 centimeters. Fine. HM over here is equal to 15 centimeters. Let us apply these numbers over here. So I'm going to get this is equal to pi by 4. This happens to be 0.2 square multiplied to 0.1 square divided by root over of 0.2 power 4 minus 0.1 power 4 further multiplied to root over of 2 times. He has mentioned the question, the acceleration due to gravity happens to be 9.8. So consider 9.8. HM over here happens to be 15 centimeter, that is 0.15 meters, multiplied to SM over here is 13.6. SW, since it is water, is equal to 1 minus 1 minus 1. Fine. Moving further, if you calculate these numbers, you are supposed to get the value of Q is equal to 0.0493 meter cube per second. 0.0493 meter cube per second. But if you see over here, he has asked you the answer in liters per second. Liters per second. So we know that 1 meter cube is equal to 1000 liters. So multiply by 1000. So you're supposed to get the value of discharge Q is equal to 49.3 liters per second. This is supposed to be your answer. Your answer is supposed to be 49.3 liters per second. Now this was a very simple question. I believe if you have done a mistake, probably, hopefully you have not done a mistake, but if you have done a mistake, this particular data, 30 centimeter data, which is a redundant data, extra data, unnecessary data, has troubled you. Anyway, I hope this question was clear to all of you. Let us now move further to the next question. Look at this question now. This question is based on fluid statics, basic pressure measurement, hydrostatic law. The question says a lake has a maximum depth of 60 meters. Fine. If the atmospheric pressure in the lake region is 91 kilopascal, P0 value has been given 91 kilopascal, and the unit weight of the lake water is 9790 Newton per meter cube. The absolute pressure in kilopascal rounded off to 2 decimal places at the maximum depth of the lake is how much? So if you look at the data, what is given? The given data over here is the value of P0. P0 has been given. The value of gamma of fluid has been given. The value of depth maximum, let us say H max or depth maximum, has been given. Depth maximum has been given. And he is demanding from you the value of pressure at this maximum depth, but the pressure is supposed to be absolute pressure. So absolute pressure at maximum depth is equal to how much? This is equal to how much? Now if you see, the value of P0 is given as 91 kilopascal. 91 kilopascal. The value of gamma has been given as 9790 Newton, not kilonewton, rather Newton per meter cube. Newton per meter cube. Maximum depth happens to be 60 meters. 60 meters. Very simple question. Again, a direct formula based question. Let us see how to solve this thing. Imagine you are having some lake, something like this. This happens to be the maximum depth. Let us say the fluid is available like this. This is the maximum depth you are having. Depth maximum. At this particular point, you want to identify what is the value of pressure in absolute scale. How to solve this? We know that the value of absolute pressure happens to be equal to P0, that is your local atmospheric pressure, plus gauge pressure. Gauge pressure. And since the fluid is incompressible, I can say the gauge pressure has a direct formula, that is gamma times H. Since I want at H max, let us say at H max. So the value of P absolute at H max is equal to P naught plus gamma times H max. Let us put in the numbers and get the answer. Direct question. Now this happens to be over here 91 kilopascal. Mind you, units are very important. If you get confused in units, you will get a wrong answer for sure. Plus the value of gamma, if you see, was given as 9790 Newton per meter cube. I can as well write this as 9.79 kilonewton per meter cube. Same thing, is it not? Same thing. So now since I want the answer in kilopascal, I am preferring the kilonewton per meter cube model. That is 9.79 kilonewton per meter cube. Multiply to the depth maximum, which happens to be 60 meters. The depth maximum is 60 meters. Use your calculator, you are going to get the answer. The answer for this P absolute value happens to be equal to 678.4 kilopascal. This is the answer you are supposed to push in your answer book. 678.4 kilopascal. If you see, he was asking the answer in kilopascal, we have got the answer in kilopascal. Very simple question, again a direct formula based question, no trick, nothing involved in this question. Okay, this was a straight giveaway kind of question. Moving further to the next question. Look at this, again a very simple question. Again something which is basically a memory based question. This is not even a formula, rather a memory based question. I myself was quite surprised to see this kind of question that has a, such an easy question to be appearing in examination. Okay, anyway, it's a good thing for students. Let us see. The question says the ratio of momentum correction factor to the energy correction factor for a laminar flow in a pipe is how much? Okay, momentum correction factor, we generally prefer beta for momentum correction factor, and energy correction factor or kinetic energy correction factor we prefer alpha, right? So he is basically asking you for laminar flow beta upon alpha is equal to how much for laminar flow through pipes. Okay, now this is something which has been memorized by almost every student, hopefully, right? Whenever we take the concept of alpha and beta, that time also we mention this thing, and whenever we discuss laminar flow through pipes, again we mention this thing. So this is a topic which has been discussed multiple times over and over again, right? Let us recall the value of beta, if you remember, the value of beta, if you remember, in the case of laminar flow through pipes is supposed to be equal to 4 by 3, or you can say 1.33. This is the value of beta we are having, and the value of alpha in laminar flow is supposed to be equal to 2. If you look at the value of beta upon alpha, that is 4 by 3 divided by 2, you are supposed to get the answer as 2/3. Very interestingly, the value of beta is always less than alpha, except in one case, which is ideal case, where it is equal to alpha. Rest every case, beta is supposed to be less than alpha, right? Therefore, the ratio is always supposed to be less than 1. The ratio of beta to alpha is always supposed to be less than 1. Straight away, you could have neglected these two answers. Just by knowing it is supposed to be less than 1, you could have neglected these two answers. Anyway, we got the answer is 2 by 3. So, answer C over here is correct. Answer C over here is correct. Very simple question, no need to mention anything further regarding this. I hope everyone has got the correct answer for this at least. Moving further to the next question. Look at this question. This question is from the topic of free liquid jet, which is similar to your projectile motion in engineering mechanics. The question reads something like this. A fire hose nozzle directs a steady stream of velocity of water of velocity 50 meters per second. So first of all, let us mention that the velocity u I am using over here is equal to 50 meters per second, given data. At an angle of 45 degrees to the horizontal, let us say I prefer theta for the angle 45 degrees. The steam rises initially but then eventually falls to the ground. Okay, so it has completed one entire projectile basically. Assume water as incompressible and inviscid, right? Incompressible implies over here that the density is supposed to remain a constant. Inviscid implies there are no losses whatsoever, no viscosity, no losses. Therefore, consider the density of air and the air friction as negligible. Now, how is this going to affect? Density of air is negligible and the friction, air friction is negligible. This basically implies there is no resistance due to drag on the projectile. The projectile is not experiencing any kind of retardation in x-axis. It is not experiencing any kind of retardation or acceleration in x-axis. Furthermore, it says that, and assume the acceleration due to gravity, that is g, happens to be equal to 9.81 meters per second square. The maximum height in meters rounded off to 2 decimal places reached by the stream above the hose nozzle will be equal to how much? So, maximum height it has reached, let us say h max is being asked over here. It is equal to how much? Now, this is something which you have been studying since your probably 11th class in the case of projectile motion. The value of h maximum, happens to be equal to how much? It is equal to u square sine square theta upon 2g. U square sine square theta upon 2g. Let us see. Let us draw a diagram first of all and understand this thing. Imagine you have something like this, okay, and you are issuing a jet of liquid which has completed an entire projectile. The acceleration due to gravity, the acceleration in x-axis is equal to 0 and the acceleration vertically downward is equal to 9.81 meters per second square. Yeah, 9.81 meters per second square. The velocity given over here is equal to 50 meters per second. And this angle is equal to 45 degrees. Please don't scale my diagrams. He's asking you what is the value of this maximum height. If you don't even draw the diagram, still you're supposed to get the answer directly from the formula. Okay. Now there is a very interesting logic why the formula of h maximum happens to be u square sine square theta by 2g. Very interesting logic is there. Apart from your derivation, you can also think logically. You see, the velocity was initially having two components. One component was in x-axis. This component was equal to how much? It was equal to u cos theta. The other component is in the vertical axis. This component is equal to how much? U sin theta. U sin theta is a component over here. Now, as this fluid particle, any fluid particle from here has reached the maximum height, what is happening? Its component in y-axis is completely lost. Since its component of velocity in y-axis is lost, corresponding head has been increased in the form of datum. Now, what is a corresponding head for this thing? The corresponding head is supposed to be velocity square by 2g, therefore it is supposed to be u square sine square theta upon 2g. So, whatever velocity has been lost, not exactly lost, it is being transferred in the form of potential energy basically. So, whatever velocity is being sacrificed, rather, let us use the word sacrificed. Whatever velocity is being sacrificed to raise the datum, That velocity's corresponding head is your datum head over here. Very simple. Anyway, let us put in the numbers and get the answer now. So H maximum is equal to U square. U square is supposed to be 50 square multiplied to sine square theta. Sine theta, sine 45, all of us know, is a standard number 1 by root 2, is it not? So sine square theta is supposed to be equal to 1 by 2 upon 2g, that is 2 times 9.81. Push in these numbers into your calculator and you're supposed to get the answer. Very, very simple question again. And the answer is supposed to be equal to 63.71 meters. This is your answer for the question.